Sharanya Sindel Rita Tab Tabla வந்து SKRTC Madurai.
Sir, good evening, sir.
Ma'am, good evening, ma'am.
Good evening, sir.
Good evening, ma'am.
We can start.
Ma'am, people are connecting, ma'am.
Okay.
We can wait for 2 minutes.
Okay, sir. No problem.
Gilbert, ma'am. Good
Good
evening,
evening,
ma'am.
ma'am. Yeah, good evening, sir.
Ma'am, shall we start, ma'am? People are
Yeah, yes, sir.
connecting,
Yeah,
ma'am.
yes, sir. Sure, sir.
We have been stored in YouTube live also.
Yeah, okay, sir.
Yes, ma'am. I welcome Shanti ma'am to give a welcome address for this event.
Good evening, sir.
Yes, ma'am.
Everyone who all gathered here. I am Dr. P.M. Shanti, working as an assistant professor in the Department of Information Technology, JJ College of Arts and Science, Pudukkottai. It gives me a great pleasure to extend a warm and heartful welcome to all of you and Dr. Gilbert Rani ma'am with us today. A person, a great distinction and a leadership has consistently inspired many through words and action. Dr. Gilbert Rani, Madam, uh, Assistant Professor in the Department of Mathematics, Arul College, affiliate to Madurai Kamaraj University, Madurai. She has completed PhD in VOC College, Tuticorin, under Tamil Nadu government Manonmaniyan Sundranar University, Tirunelveli in 2012. She has experience in undergraduate 11 years and postgraduate 3 years. She is working as assistant professor in the um, Tazim BV Abdul Qadir College for Women, Kilakarai, and Fatima Michael College. And finally, he is working as a assistant professor Arul College in Madurai. She has attended and organized so many conferences and workshops. She published many research work paper in national and international journals, and she is acted as a resource person and to give us a special lecture on motivational speech for mathematics students, cyber mathematics, mathematical research in fuzzy set, rough set, and soft set. Data analysis using MS Excel, MATLAB for scientific research, interactive teaching, learning, and assessment tools in cyberspace, a prime look for our programming. And we create a e-content. Example, introduction of metric space, Abel's theorem for radius of convergence. She has received so many awards and achievements. The Best NSS Volunteer Award in 2003 got from Madurai Kamaraj University. Best Outgoing Student 2006 and College Gold Medal 2007 received from BBC College and Excellent Resource Person Award in 2020 from Research Culture University, Society, and Indo-ASEAN Maurice French Distinguished Scientist Award received at International Dialogue on Unsustainable Goals, Quality Education, the future. So once again, I will welcome Dr. M. Gilbert Rani Madam and other persons and participants. Thank you.
Thank you, Shanti ma'am. Good evening, everyone. It is great pleasure and honor that I extend a warm welcome to our esteemed resource person, Dr. M. Gilbert Rani ma'am, Assistant Professor at Arul College, who has graciously joined us today for the first International Faculty Development Program. Dr. Gilbert Rani ma'am is highly respected in the field of computer science, and her expertise in granular computing, particularly its application to image processing, is widely recognized. Her dedication to research and education makes her an ideal leader for today's session. We are truly fortunate to have her here with us to share her vast knowledge and insights. Once again, welcome to this enriching and interactive session, and thank you for being with us. Gilbert Rani ma'am, shall we start the session, ma'am?
Yes, ma'am. Good evening to one and all.
Ma'am, it's audible?
Yeah, yes, ma'am. Am I audible to you?
Yes, ma'am.
Am I audible? Yeah, okay. Good evening to one and all gathered here. Yeah, am I audible, ma'am?
Yes, ma'am, you are audible.
Yeah, okay.
Ma'am, you can give your presenting in full screen mode, ma'am.
Yeah, okay, sir. Good evening to everybody. I'm very happy to deliver my lecture on framework of granular computing in image processing in this online
FDP program. First, I would like to thank the publishers and give this opportunity, uh, Dr. Satish Kumar sir and his organizational co-workers. So now we are going to our presentation. Today our presentation frames what is granular computing and a small history of granular computing, and then what is granule and one model granule which was proposed by Pavlov, and enter into the image processing, and then what is the relation between how do you connect granular computing in image processing. These are the preamble of this presentation. Granular computing is not new to us. Last 2 decades, the granular computing is came into the computer field, but we are very known about granular computing instead of the soft computing. Soft computing is a part of the granular computing. So granular computing is a very biggest thing in this computational world. What is granular? It's granular in the sense we can divide the large segment into the smaller part. Where the word granular came from, who is coined the first term granular, is the theory of fuzzy information granulation, which was proposed by Zade at 1997 itself. At the time, that mathematician just divide the large things, yeah, that means the closed interval 0 comma 1 into the particular small pieces, that is called the granules. So he named that information nothing but fuzzy information granulation. After that, this granulation is not a big one in this mathematical competitions, but that many competitions it was used unknowingly. This theory of fuzzy information granulation builds on existing machinery of fuzzy information granulation in fuzzy logic, but takes it to a significantly high level generality, and its foundation and suggestions new directions. So granulation computing is a superset theory of fuzzy information granulation. Nowadays, this granulation is very much used in rough set theory and interval computations, and is the subset of granular mathematics. Many authors argued that information granulation is very essential to human problem solving, and hence a very significant impact on design and implementation of intelligent system. Now, what is granulation? Granulation of a object capital A leads to a collection of granules of particular object, with the granule being clump of points, that is objects drawn together by indiscriminability, similarity or proximity or functionality. This is like a partition. That partition labeled by some similarity relations or some similarity functions or some proximity characteristics. That is called granulation. Which granule involves in the construction of granulation, that depends upon the data, which information we received. Which information you received, that is the main part of the granulation. Suppose we are talking about the age of the computer, which type of computer introduced in which year, and which type of computer is greater than which type. So these type of problem, we can granulate the computer, not a computer but the year. Just we take 1970 to 1999, these year we have the revolution. After 1990 to 2000, we have certain invention in computer field. So these are called the granulation. So here the granule is years. Okay, depend that granule, which is depends on the types of computer. This is called the granulation and granule. These granule, 1 minute. Yeah. So how these granules are formed? Already I give one example, the number of years the computer revolutions which was started. So these three things involves to separate the granules from our data or information what we received. First one is groups, second one is classes, the last one is clusters of elements. The three things are gives the same meaning, but in depth we have deviations. Groups in the sense, just we call any type of collection is called group, not in algebra, normal way, in a oral thing, not in mathematical literature. We just talk about groups in the sense we can collect some other peoples or some other things or some other objects, something. It is called some groups. What are the classes? So the classes have some subsets that is called classes. What is the cluster of the elements? What are the elements have the same futuristic? What are the functions have the same character? These are called the clusters. But these three have a common one thing that is called similarity. That similarity forms the granules. So, wow, how do you construct this granules? We know that granule is only depends on the similarity. What are the things we have this construction of the granules? That is, first one is the formulation, next one is the representation, and how we interpret the granule. That is very very important thing. First, the formation. How do you form this granules? How do you form these granules? Depends on the characteristics of the given data. At the same time, we are looking at desires, what we have to give the data and what our desire, these one comes as a output. So depends on our output, we can separate the given data, that is the formation. This is the first step. Second one, just we glub all the things according to some relation or according to some similarity or according to some proximity or functionality. Just we separate the groups. Now we formate. This is one group and this is one group and this is one group and that is one group. Just we put it 1, 2, 3, 4, 5. Okay. What is the representation? How do this granule represent? These are the set of all computers. These are only set of all fastest computers. These are all the set of all labs. Like that, we can represent our groups, justifying, just as justify why we separate this group, why we form this group, in which criteria we can separate this particular set of objects in a single group. Why we put it into the one capsule of this type of object, just representation. Then interpretation. Suppose you construct one granule and give a representation. This one is A and this one is B and this one is C and this one is D. But what is the reason and goes on? How do you interpret that things? This is very, very important. This formation and representation is common for all the sets. Suppose we can take our upsets or interval sets and fuzzy sets and all other hybrid sets of fuzzy and so on. This formation and representation is same, but the formation depends on some other modes. For example, in our upset, we can take a equivalence relation. For a fuzzy set, we can take membership functions, and interval we can take the intervals. So like that, we can form this, separate this data, and then common things formation and representation is orally form all other sets. But the interpretation is very, very, very different in all the sets. Each and every set have a different type of interpretation according to your formula or method which was used in formation. That is very, very important. That interpretation gives the original desired output. So we can consider these three as in the construction of granules. Suppose we break one big data into the granules. Just we consider first how we formate this granules, and how do we represent this granules in the correct sense, and how we interpret the granular sectors. This is very, very important. The next one is human cognition. In our body, we have certain granules up to neck. We have we say that this is a face. These face have some lips, nose, eyes, ears. This is one segment, and again neck is another segment. And after the neck, we have chest, stomach, and legs. These are each and everything are segments. These segments may be called granulation. Next, these granulation in the sense decomposition of whole body into the parts, face, hands, shoulder, stomach, leg, like this. How we organize these things? Just we split. And how do you give a good meaning or correct meaning for these splitting areas? That is called organization. That is the integration of parts into the whole. Next question. That is the association of cause and effects. Suppose we decompose or integration. When we decompose it, we can get some loss. When we integrate, we have some effect. So these called the third one cautions. Um, Human being have developed a granular view of the world as objects with which mankind perceives, measures, capitalizes, and reasons are granular. Suppose one important news spread over all the world means that important message is same, but we take it as an old perception. So according to our perception, I can say one thing about particular news, and another one say something, and another one say something. Those who are say the same thoughts or same words, they are form single group. That's why objects with which mankind perceives or measures or conceptualize or reasons are granular. That is called, we say orally, like-minded persons. These are all like-minded persons. That's why they are talking about this, like this. In many situation, we don't receive a full data. Nowadays, we can receive so many data from so many sources. Sometimes it is overwhelmed. Sometimes it is incomplete or uncertain or vague informations. So no one can fill it the incomplete informations. Suppose if you put some X means that particular data provider gives some Y. So totally the data information gets wrong. So no one predicts which element comes into the incomplete cell. But we can collect those cells have an element and those not. So we can separate. So automatically the word granules comes here. So this is very basic things. In my introduction, I said we are knowingly or unknowingly we use granules. We can use it to separate anything based on some reasons, based on some classifications, based on some characteristics, based on some features. So the lack of information may only allow us to define granules rather than individuals. We can't fill it. If you fill it by own, that incomplete data gives the wrong interpretation. So in that vagueness, We can split the cells in terms of similarity. Granular computing can be defined as an emerging research field that stimulates human cognition to solve complex problems by analyzing and summarizing various research fields such as artificial intelligence, machine learning, data mining, and feature extraction. It focuses some structured solution to the problem by prescribing and understanding how we split the granular. How do you get the granular structure for a particular problem? Just we solve the particular complex problem by granular. So last we can sum up. We get the good result from this granular computing. Granular computing emphasizes the application of different formal systems and technical methods to solve practical problems. That is very, very important. Practical problems. That's why we used. These reasons GRC have been applied to uncertainty handling in decision analysis. Nowadays, this is granular computing used in the multi-criterion decision analysis using the such a formal settings as intervals, fuzzy sets, rough sets, and shadow sets, and so on. Now, suppose we have a large scale of problem, just divide the total problem into the smaller one. Already I told, suppose we have a complex problem, suppose we have incomplete data, just we can split it up. We will term this process information granulation. This idealist form partition, that is a classification, is the key notion for rough set. Laterly I wish to say what is a rough set theory, and granulation is the very basic brick of rough set theory in the soft computing. To elevate that problem into the conceptual space, nowadays we have a data, we receive a data in terms of number or in terms of sentences. Suppose if you want to get some desired output, we can split this number into sentence formation or sentence into number formation. For the first one is called fuzzy and second one is called subsets. This rough set is also the tool for knowledge representation through data. So these three sets are knowingly or unknowingly placed with the granules. Next, to elevate the problem into the conceptual spaces, in the partition case, the space is the quotient set. What is data granulation? Data granulation emerged as an important paradigm in the modeling and computing with uncertainty, exploiting information granules as the main mathematical constructs involve the context of granular computing. This is very important. Okay, where we use this granular computing? First, we see what is granules, how we split the granules, how we identify these granules, and how it is works, and where we use. What is the use of this granular computing in mathematics, in decision making? Now, where we use this basic ideas and principles of granular computing in the field of computer science. First one is the artificial intelligence. What is artificial intelligence? All of you know what is artificial intelligence. Artificial intelligence is the structured coding. It is a trained coding which is based on the experience of human being. So such kind of intelligence we supply to the system, but artificially. That's why this is called artificial intelligence. All the records, all the experience, all the history of the event already supplied to the system. Next one is the cluster analysis. How do you separate the similar things? You may know the very good cluster analysis is fuzzy K cluster. K distance, all the elements, those who have a K distance between the other elements, we can separate it and find the value of K. Once you have a value of K is fine for your desiration, this K is okay. K nearest cluster analysis. Interval computing, where we occur in this desired output. Next, quotient space theory. Which condition, for which condition we can give this desiration. Belief functions, machine learning, data mining and database and many more. Data mining is again come to the part of artificial intelligence. Database, we have a big data analysis now. Where come to the big data, just we can split it into the smaller group and then we can calculate all the things with efficiently. Then we have a little bit accurate answers. You know, beliefs function. We know what is machine learning. Machine learning is also the part of the artificial intelligence because artificial intelligence came to the world at 1950 itself, whereas the machine learning comes after that. Artificial intelligence was invented by Alan, but at the time that man Alan didn't know that is called artificial intelligence. He wanted to play one co-player for playing a chessboard. That's why he make one co-player using the artificial intelligence. After that, DMARC University named this is called the artificial intelligence for 8 cross 8 chessboard playing that Alan wanted to some other persons. Whereas think fair, it is called
அடுத்து எடுக்காங்க ஒரு சட்ட மெஷின் வச்சிருக்காளா எந்த ட்ரெஸ் இதை போட்டு தொலைலாம் சளிப்ப ஆரம்பத்துல கத்திக்கிறியா கேட்கறானா நல்லா கூட்டிட்டு போற பெருசு
Ma'am, what happened?
yeah, some noise is there. That's why I stopped. Okay.
Okay, ma'am. Now it's okay.
Yeah. Um, so go beyond 4. This is one game that game contain 19 cross 19 cells. So a little bit difficult that DMARC University students faced to play this 19 cross 19. Imagine that how many cells are present in this playing. So that time the artificial intelligence came out to the world. After 2000, the artificial intelligence got a very big figure in this world and into this computer world. So this is a story of artificial intelligence. Now we are in generative artificial intelligence. That's why we can take an artificial intelligence anywhere, GENAI. That is called the generative artificial intelligence. The three different tasks of artificial intelligence are cognitive level, expert level, and the last one is perceptual. The first word cognitive level in the sense what are all the work for the brain, how we construct one machine, how we tackle this problem, how we frame this syllabus, how we get the information for particular event, how we analysis for comparative analysis or critical analysis or whatever it is. That is called the cognitive level task. So, sir, some others or please put off your mic.
Siddhan sir, kindly mute your mic, sir.
Okay. So the first task is cognitive one. The second one is expert level task. Expert level task in the sense, suppose we can produce one machine with a multifunction. So that is called the expert level. Suppose we produce one machine, you give a guaranteed for 10 years. Before 10 years, it met some more mistakes or some defects in this machine. So the intelligence is just quickly analyze where the machine lock, why our warranty get expired before 10 years. That is called expert level task. The last one is the perceptual. Now we are getting a voice message and voice cast typecast and face recognition. We lock a pattern using the pattern. This is called the perceptual task. These three tasks are done by only the generative artificial intelligence. That's why we nowadays, all the places, GENAI, there is a generative artificial intelligence. These all the things comes into the artificial intelligence. So this granular computing is used in artificial intelligence programming. So automatically this granular computing is a part of the artificial intelligence. Now I want to propose or I want to provide one model for granular computing. That is Pavlov model. Uh, Pavlov, a mathematician, is a very great mathematician. Uh, he found the rough set which has a lower approximation and upper approximation and so on. Now, he proposed one granulation for granular computing. Um, Basically, the basic brick of this rough set or Pavlov set is equivalence relation. You know that what is equivalence relation? We have a three different relations is there. That is reflexive, symmetric, and transitive. Without transitive, we can't live in the world. One is relative to other, and another one is relative to other. The first one is relative to the third one. That is called the transitive. So without transitive, we can't imagine any human being live in this world. So this is called the equivalence relation. We are related to ourselves. We are suppose we love someone, they should love our. This is called the symmetric and reflective. So these are called the equivalence relation. Suppose we take U as a universal set and E is a subset of U cross U. That's why E is in the form of the paired, ordered pair. So each equivalent class is considered as granule, consisting of indistinguishable elements. So now the granular or granulation done by equivalence class. This is very important. Equivalence class was constructed by equivalence relation. Equivalence relations or identify these three reflective, symmetric, and transitive laws. Next, the particular semantic interpretation of the equivalence relation is provided by the notion of information table. Already I told RUPSET is identified as the knowledge representation tool, the tool of knowledge representation. That knowledge representation is nothing but the information table. That information table gives the attributes, conditional attribute and decision attribute. From the conditional attribute, we can get the predominant attribute which rolls this information table. Now come to the decision attribute that play some other things. So these things are important. Two objects are equivalent if they have exactly the same value with respect to the set of attributes. These are That's why we can say these two objects are equal. Thus, the equivalence granule is characterized by an equality constraint. First we write what is equivalence relation. Then we construct equivalence class from the equivalence relation, and then we can identify the information table where the find the interpretation. Now we have a equivalence granule. It is characterized by the equality constraint. Any arbitrary set capital X can be characterized by a pair of lower and upper approximation. Now, suppose we consider the equivalence relation is R. What is a lower approximation? So, suppose we take one equivalence class X. That equivalence class is a subset of R. Those elements are lower approximation. That equivalence class have a common element with the equivalence relation that is called the upper approximation. So now we have two elements. First one is the lower approximation. Second one is the upper approximation. So we can find the middle approximation that is called a boundary. Boundary is nothing but the difference between upper approximation and lower approximation. So where we use the lower approximation and how do you get the upper approximation? By using our equivalence relation, you can find the lower approximation as well as the upper approximation. Where we have the low frequency on the set, by using this equivalence relation, we have the lower approximation. For which data or which element we have the high density, we receive the upper approximation. So the range of approximation is wide, whereas lower is very tiny. So based on this approximations of set, one may perform data analysis and mining tasks in information table. What is the data mining? This very simple example of data mining is, suppose 2 days continuously I watched WWE in my YouTube channel. The third day, when I opened this YouTube channel, all the videos are related to WWE. That is called data mining. Just that execution point, get my desire, filter all the things based on my desire, all the filtered things is listing out. That is called the data mining. Not more than that. What is data analysis? In data analysis, what we want to perform. Suppose we want to categorize. Suppose we want to get a neighborhood system. Suppose we want to clustering it. So now we eliminate the noisy. These things are called the data analysis. So in this rough set, from the information table, we can perform all the things in the name of attribute reduction, dependency analysis, and learning of decision rules. So already I told you we have a two type of attributes used here: conditional attribute, decision attribute. Conditional attributes play a vital role which gives the decision attribute. Decision attributes are only depends on the conditional attributes, not all, but some of the conditional attribute. That attribute is called the core attribute of the information system. So this is called the Pavlov model. The next one is the very simple. This is the granular computing of rough set. This colors says which one are lower bound and which one is upper bound and which one is the boundary. So this is the granular computing in RAPSET. Next one is very simple model of granular computing. Each granule represents certain concept such that each element of the granule is an instance of the concept. Granules can be constructed from information table as in done for subsets. Already we saw what is subsets. So main concentration is on operations or granules. We consider three models. The first one is power algebra. The next one is interval number algebra and interval set algebra. It's only mathematicians only known for these things because we have so many symbols and so many operations on functions are involved. There's power algebra in the sense all of you know that what is power set, and that power set is goes to the another power set. We can draw one map or one relation between these two power sets. Using these power sets we can create one function. Based on this function you can construct the model. So the universal algebraic construction approach, this one is a universal algebraic constructor. So using this power algebra, so many good results which was founded by algebraians. Next one's the interval number algebra. Just we take the interval upper bound and lower bound. Just we take the real numbers between the upper bound and lower bound. Just we pull it to what is the addition of the two subsets and subtraction of the two subsets. That is algebraic operations. Just be done with it. So one can lift any operations on a real analysis, real numbers, such as a minimum and maximum to power operations on a interval of real numbers. So it can be extended into fuzzy arithmetic with fuzzy numbers, because we are talking about the fuzzy set on closed interval 0, 1. Now we're talking about just a closed interval with upper approximation element and lower approximation element. That's it. The last one is the interval set algebra. Interval set algebra in the sense just we take two subsets in power sets and we can write these two subsets as a interval. So interval set algebra is a combination of power algebra and interval number algebra. This is very good models in granular computing. So this is a general scenario. We have three different aspects used when we have a granular computing. First one is a philosophical perspective. That is a structured thinking. How we get a granule, how do you form, and so on. The second one is computational perspective, structured information process we want. Next one is the methodological perspective. This is not in the sequence. We get it in any order. Just I want to say in this sequence, structured information processing or structured think in the sense granular computing works with the pyramid consisting of different sized information granulae. So knowledge in intensive systems, structured information processing is necessary. This structured thinking is nothing but the granular computing, integrating two complementary philosophy. Reduction or just reduction is one hand and core is another hand. So two different things. This is called a structure. How do you the system thinking come to the reduction and come to the shift one part into the another part? Against merge one all the parts into whole. Already I told into the human cognition. So these things are the different area in granular computing. Structured problem solving, in the sense the structure plays a crucial role in problem solving. Just a problem, structured problem solving is studied by many authors It is effectively granular computing is to present a set of principles that is very important and demonstrate the work of this principle and how it is work and where we lack we have and so on. These three things are the perspective for granular computing. Now time is very soon. This is 6:50, so I'm emerged. Sorry. These are what is image processing. Image processing is the process of transferring an image into a digital form. That is very important. Digital form and performing certain operations to get some useful information from it. So this is called the image processing. Just we get one image, we transform that image into the digital form. Suppose we want to eliminate some part of this image, just we can eliminate. Just we add some more things into the image, you can add. You can darken in some places, you can darken it. And how it is possible for in the normal thing. That is the things which is hidden in this image processing. So types of image processing. These are the types of image processing. In the image processing, we have visualization, that is find objects that are not visible in image. For example, if you want to color the Eastman color photo or black and white photo, just imagine that. Then next one is the recognition, that is detect objects in the images. And next is sharpening and restoration, create an enhanced image from the original images. Then pattern recognition, this is the very important image processing, because all other things are very easy, but pattern recognition is very 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 different from other things, and it's very sharpened and is very vast area. Measure the various patterns around the object in the image. How we form the pattern, that is very important. How we form the patterns, is it in shape or it is from a function, and so on. And retrieval, browse and search images from large database of digital images that are similar to the original images. Now these are the fundamental image processing steps. Image acquisition, there is image acquisition is the very first step in the image processing. um, it involves retrieving the image from the sources, usually hardware based source. Next one is the image enhancement, is the process of bringing out, highlighting certain features of interest in an image that has been obscured. This can involve changing the brightness, contrast, and so on. Next one is the image restoration. So, name itself, this is a process of improving the appearance of an image. However, unlike image enhancement, image restoration is done using the certain mathematical and probabilistic models. Next one is the color image processing. It includes we can number of colors, modeling techniques, we can use it. Next, wavelets and multi-resolution process. All of you know that wavelets, in the sense, signal processing also comes here. So wavelets are used to represent images in various degree of resolution. The images are subdivided into wavelets or similar regions for data compression and for pyramidal representation and so on. Next one is the compression. The name itself says what is compression, and the morphological processing is a set of processing operation for morphing images based on their shapes. Next, segmentation. We know that what is segmentation. Representation and description. After an image is segmented into the regions in the segmentation process, each region is represented and prescribed in a form suitable for further computer processing. That is called the representation. So there is a representation deals with the image's characteristics and regional properties. Description deals with the extracting the quantitative information that helps differentiate one class of objects from another thing. This description is not done in a Word document fully. That's why we we can lose many more background in images when we use the Word document. Next one is the recognition. Recognitions in the self it assigns a label to the object based on its description. These are the fundamental image steps. Benefits in the sense we have so many benefits, so many benefits of image processing. We have a constant growth in image processing. If you use a professional, that image processing is very good thing. Or if it is not, we lose our technical knowledge. For the image, digital image can be made available in any desirable format. We can develop improved image. We can improve X-ray, photo, photo negative, and so on. Yeah, it helps to improve the images for human interpretation. The pixels in the image can be manipulated to any desired density and contrast. We can derive a picture which was very much fully visualized in Onida TV. So nowadays the pictures are very good resolution. But at that earlier age of before 20 years, and so we have some Onida TVs, some other TVs which is not in a smart screen. That time we can see the pixels, so many colors. The pictures consist of the rectangle and triangle and so on. Nowadays, this pixels is used in the pattern recognition. Sorry, okay. Image can be stored and retrieved easily. It also for easy electronic transmission of image to the third party provider. Suppose I take this image. Now we have this is an example of binary image contains the corrupted symbol shape. So the symbols are some grids are filled with black, some grids are not. But we recognize that this is our. So here we have a binary image. Now we just fix one function by using the rough set. Just we get this type of shade. Now we involve just we shade and crossed. This one is the lower approximation of the symbols. And this shade is nothing but the difference of upper and lower approximation of the symbol. That is called the boundary. When we cross the rough set, we talk about lower approximation and upper approximation. The difference between the lower approximation and upper approximation is the boundary. So these places occupied by boundary of the rough set. These are called the lower approximation. So how do you put this shadeness in the sense using one function? That function is the work on hidden layer. Next, the main advantage of this estimation and granulation techniques is the non-probabilistic qualities. We do not need the large sampling of pixels to provide the accurate estimation values. When we work on this image processing, we should know the probabilistic qualities. How do you get the probabilistic idea on this? Otherwise, we can't get. Suppose if you want to mark on one football, we can using the Pythagorean theorem. Without a Pythagoras theorem, we can't get a full-fledged marking on football court. So mathematics is omnipresent. Okay, as a result, very efficient algorithms of granulated image processing are implemented for the different problems of image processing and analysis on C++ and Java languages. So this pictures, come to this picture. Now look at these four picture images. First, this one is the original image. Next, we this image contains the pixels. Now we have the darkened in the visualized area on the original thing. These are the shadows and these are the noise on this data. Apart from this, these things are in darkened. These one is. Again, just be removing this grid. Just be crop these one. Now we can supply your colors on all other things. So these are the image processing by using the rough set or approximation space. That rough set is based on granular computing. Just granulate. Those elements are present in lower approximation, those are present in upper approximation, those are in boundary approximation. Partition and granulation is not same. These are different. So with this slide, I want to finish my presentation. If you have any doubts and queries, kindly ask.
Madam, very good evening. I'm Anandar from Chennai.
Yeah, yes, ma'am.
Actually, this presentation was extremely good. I don't have any doubt at all. I came to know about this granular model very well, and I thank you so much. If it is possible, can I have the recorded link or the PPT for further use?
Yes,
Is
ma'am.
it possible?
Recorded link have been stored in YouTube live, ma'am.
Okay, thank you so much.
I will be sent the link to you.
Yeah, thank you. Thank you so much, sir. Very nice of you. Thank you. It's in a very understandable format, and after a long time, the knowledge about this granular clustering and everything, and it gives me a very in-depth knowledge about it. Thank you so much.
Thank you, ma'am. Thank you so much.
Thank you, ma'am. Other participants, can you get your suggestions and doubts from ma'am?
Thank you, ma'am. Ma'am, shall we go to the vote of thanks, ma'am?
Yeah, yes, ma'am. Sure, please.
Okay, ma'am. The faculty, Monica, give me a vote of thanks, ma'am.
Good evening, everyone. On behalf of Laila Publication and Press, I extend my heartfelt thanks to Dr.M.Gilbert Rani, ma'am, Assistant Professor at Arul College, Madurai, for her insightful presentation on a framework of granular computing in image processing. Our expertise has greatly enriched our understanding of this field. A special thanks to all participants for our active involvement. Once again, thank you all for making this program a grand success. We look forward to future learning and collaboration. Thank you all.
Thank you, one and all.
Thank you, Anandar.
Thank you, ma'am.
Thank you, sir.
Thank you so much.